All right, we're going to start talking about area between two curves. And in order to find that area, it's a good idea to try to figure out which graph is on top. So to me, the quickest way would be just to go ahead and try to graph this. So if we factor the top, we're going to get x plus 1 times x plus 1, or x plus 1 all squared. And then we know over here we have a line, and our y-intercept is at 5, and we have our slope, which is 2. So let's go ahead and do a little sketch here. And so our parabola is going to bounce at -1. It's going to look something like this. And then we know our line, we're going to intersect at +5, and our slope moves up. Now notice it's just a nice little quick sketch, nothing perfect here, and our bounded area is this side inside here. So what we need to do is to integrate, and we need to find our endpoints, or those points of intersection. So we need to integrate from endpoint to endpoint, and it would be the top function minus the bottom function. And then the rest of it is just working out the problem. Well, how in the world do we find those endpoints? Well, we set our functions equal to each other and solve. So because we're setting them equal to each other because they're intersecting, so they have to be equal to each other at those points. So I have x squared plus 2x plus 1 has to be equal to 2x plus 5. Let's move everything over and set up some kind of factoring. Those two x's will cancel. I'll subtract 5 over. And notice that we get x equals, I don't guess I need that extra parentheses there, sorry guys. So I get x equals plus or minus 2. That's going to be my endpoints. We don't need the y's yet because we are just looking at the inside and integrating from x to x. So from -2 to +2. And then we're going to talk about the top function. Well, my top function is the line, 2x plus 5. So top function minus the bottom function. And this is where people tend to miss their signs here, and I understand why. So be super, super careful here. And so there's the setup to find the area. So we would integrate from -2 to 2. And so let's see, we're going to have a negative x squared, aren't we? And then I'm trying to get these in order. The 2x minus 2x is gone, and 5 minus 1 is going to be +4. All right, so now we've combined our like terms. Now let's integrate. So we're going to have negative x to the third over 3 plus 4x, and then we're going to evaluate all of that from -2 to +2. All right, so let's see, if we plug in +2, I'm going to have -8 over 3 plus 8. Well, let's see, what is 8 over 3 going to be? 8 over 3 is going to be 24, isn't it? So there's my top endpoint minus, now let's do the bottom endpoint. We have a -2 cubed, which is -8, but the negative out there is going to be +8/3. And then that's going to be -8. Well, -8, that's minus 24 over 3. And let's see, so we've got minus here. Yep, that looks like that's going to work out. So let's see, -8 minus 8, that's -16/3. And then let's see, 24/3 plus 24/3, so that's plus, and if we add those, that's going to be 48/3. And so I'm just going to, well, we can leave it like this, or we can combine them. That's going to give us what, 32/3. So that's going to be our answer. So again, this was just a matter of setting up the problem, seeing which function's on top, and finding your endpoints. Okay, so looking at our next problem, the same idea. Notice we have two parabolas here. And so I would go through, let's see if we can find their endpoints first. So we would set these equal to each other. So let's see, what are we going to get? We have x squared minus 4x plus 3, and that's going to be equal to negative x squared plus 2x plus 3. And let's move everything over to one side. So I'm going to have 2x squared minus 6x, and those 3's are going to cancel. So that's sweet. Factor out a 2x, so I get x minus 3 left. And so notice my two endpoints I get, it's going to be x equals 0 and x equals 3. So automatically I know I'm integrating from 0 to 3. Now, as far as graphing this, we can go through and graph. Another way to figure this out, let's pick a value between 0 and 3. Let's say we're going to pick 1. So I'm just going to pick 1. And so what I'm going to do is plug into both equations, and whichever one has the larger values, the one that's on top. Since it's in this form, it's kind of a little bit tougher to work with, and a lot of people don't want to do the graphs. So pick a number, again, in between your endpoints and see which value is bigger. So if I pick 1, up here I'm going to get 1 minus 4 plus 3. So that's going to give me, it looks like 0. No, it's not going to give me 0. What in the world? Oh, yeah, it is. Sorry, brain fart. All right, down here, if I plug in 1, well, I'm going to get negative 1 plus 2 plus 3. So that's going to give me 4. So notice this one is on top. So that means that we're going to have here, we're going to integrate negative x squared plus 2x plus 3, that's our top function, and we know it's the top one because it had the larger y value, minus the bottom function. So that's going to be x squared minus 4x plus 3 dx. Collect your like terms before you try integrating this mess. So let's see, we're going to have a negative 2x squared, 2x minus a negative, so plus 6x, and 3 minus 3. So again, those cancel out. Now let's go through and actually integrate after we've collected our like terms. So we're going to have negative 2x cubed over 3 plus 6x squared over 2. And this is evaluated from 0 to 3. So that means that we're going to have negative 2 times 3 cubed over 3 plus 6 times 3 squared over 2. And then minus, the bottom part is 0. So let's see, we can leave our answers just like this. Now, if it was multiple choice, you would have to finish out the problem, but if it's free response, just leave it. And you could see on both places, but for now, let's just focus on knowing how to set up the problem. The rest of it will come about. All right, so what about our next problem? Where we have y equals x squared and y equals x cubed. So again, to find where these two intersect, we're going to say, well, x cubed equals x squared. Do not cancel x's. You are going to subtract x squared over. Try to cancel x's, you're going to lose some answers. So we have x squared equal, or x squared can factor out, and then we have x minus 1 left. So we have x squared, or x equals 0, and x equals 1. So let's see what this is going to look like. And we can pick a value in between here and try to figure out which one is on top if you want to. Between 0 and 1, we could pick 1/2. Let's see, 1/2, if we choose that, then that tells me that here, if x is 1/2, y is 1/4. And down here, of 1/2, it's going to be 1/8. So notice 1/4 is larger than an 1/8, so x squared is on top. If you don't want to do that, we could try graphing this since these are nice functions. We know x squared looks like that. And then our cubic function is going to come down, and let's see, gosh, what does that cubic function look like? It's going to look something like this, and of course they would have intersected here. It's just I stink at drawing there. So let me try that again. So let's get my parabola a little bit skinnier, and that might help. And then our cubic function does something like that. And so there's my bounded values. So again, I like just picking a number and seeing which one has the larger value. So we're going to integrate from 0 to 1, my top function minus my bottom function. And then there's nothing here to combine like terms, so we are going to go straight to our integration. So we're going to have x cubed over 3 minus x to the 4th over 4. And we're going to evaluate those from 0 to 1. So here again, just plugging in the rest of this. So that's going to give me 1 cubed over 3 minus 1 to the 4th over 4. And then if we plug in a 0, we get 0. And we can leave it like that. All right, moving on. Let's see, to our next set of problems, we're going to be doing the same thing. So, all right, with our next problem, this x minus 1 all cubed business. Well, let's see. This one, it's going to look a little different. We do have our cubic function, and it's moved over to the right, and it's going to intersect here at 1. So it's going to do something like that. There's our cubic. But then we've also got, let's see, our line down here, and it's going to do something also. So, and let's see, I think that line, these are going to intersect both of them at the same place. So it looks like we might have a couple of points of intersection. We might have a point here, here, oh dear, and there. So, and what happens is when we have that many points of intersection, that means our function, as far as which function's on top, that's going to change. Well, let's see, where in the world would these two values be equal to each other? So let's look at it, and a lot of times just reasoning out and looking at our graph is a little bit faster than the algebra. Well, to me, it looks like when x is 1, you're going to get 0 on both sides, so that has to be right. It looks like when x is 0, you're going to get the same value on both sides. And it looks like when x is 2. And so graphically, that looks like that might make the most sense, because here's our 0, here's 1, and then over here would be 2. But just plugging in, very few things are going to satisfy that. So, and the only numbers that if you have them equal and then also cubing it, it's going to be 1s and 0s. There's no other way to get 1s and 0s. So let's think about this. I'm going to have to integrate two different sets. I'm going to have to integrate from 0 to 1, and just keep this in numerical order, and then plus, and then I'm going to have to integrate from 1 to 2. And I need to try to figure out, well, which function's on top? Well, from 0 to 1, let's pick a point in between that like we did the others. Now, we could rely on our very pitiful graph here and see, well, maybe the cubic value's on top, but just to make sure, a value between 0 and 1, let's pick a half. So if I plug in a half right here, a half minus 1, that's negative a half, and if I cube it, that's negative 1/8. Over here, I'm going to get negative half. So negative 1/8 is closer to 0 than negative 1/2. So it's going to be larger. So our cubic function is what should be on top in our interval from 0 to 1. So we're going to set up and have x minus 1 all cubed minus x minus 1. So there's our first one, dx, and then let's see what our second one is. Well, our second one that we would integrate from 1 to 2, they're intersecting, so they're going to swap. So after they intersect, now the line will probably be on top, and we can still pick from 1 to 2. We could pick 1.5, but if we do, we'll see that they do swap places. So now the line is on top, and then our x minus 1 all cubed is in the bottom. And usually if it's this involved, they'll just ask you to set it up but not solve. And that's what I'm going to do here. Don't worry about finishing this out. As long as you're getting the idea of how to set this up, it'll be okay. All right, and number 5, 1 over x squared. That's not something you see quite a bit of anymore, but the graph of 1 over x squared is taking that 1 over x function and it's flipping all the negative values over. So you have something like this. There's the graph of 1 over x squared. And the graph of y equals 0, well, that's just your x-axis. And then they're telling us this right here, these are our endpoints. This is what it's wanting us to set up. So we're going from 1 to 5, so it's chopping off. And we're integrating this little area inside here. So when we integrate this one, that bounded area, well, the bottom function is y equals 0 and the top one is 1 over x squared. And our endpoints were given to us as from 1 to 5 of 1 over x squared minus that bottom function, which is 0 dx. All right, and so when we integrate this, remember x squared, we need to flip that over to x to the negative 2. 1 over stuff does not always lead to natural log. It is just if it was 1 over x. 1 over x squared we can do stuff with. And so if I add 1 to the exponent, and then that tells me what to divide by, and then I evaluate that from 1 to 5. So that's going to be negative 1/5 minus negative 1, so plus 1. And you're welcome to stop there. All right, and let's see, the same is true here with the square root of 3x and then plus 1. Graphically, what's going on here, we have a square root function moved up 1, so we have a square root function that looks like that. And then the line y equals x will come through and slice it like this. And so they're giving us the endpoints here, so I know we're integrating from that endpoint. We just don't know what this other endpoint is. So we'll have to set these equal to each other. So x equals the square root of 3x. Square both sides, so I have x squared equals 3x. And then subtract our 3 over. So x squared minus 3x equals 0. Factor out an x. And so we see that when x equals 3 or when x is 0. And by the same reasoning, you could have used the reasoning that we did on the earlier problems here to come up with those two values if you wanted to. So we see that we are integrating from, let's see, 0 to 3. And our top function, which we can pick a value in between here if we wanted to and plug in. Or we can go ahead and say, well, we did move up 1, so chances are the square root function is on top, square root of 3x, and then plus 1, and then minus our bottom, and then all of that dx. All right, and there's the setup of it, and then the rest of it, you can go back and finish if you want to.